Okay, let's get started. Today we'll be talking about this topic called indices, all right? And it's a very, very simple topic, and I hope to complete within an hour. Okay, now what's this word indices? What does it mean, right? Now, indices is really the plural of index, all right? So if you look at a number like this, if you see a number like this, 2 to the power of 10, now this 2 here, that's called the base. All right, so 2 is called the base, and 10 is variously called the index or the power or the exponent. You can call it the index, you can also call it power, you can also call it exponent. All right, choose the term that you like. All right, index, power, or exponent. All right, so this is the base, and that's the power or exponent. All right, so indices is really the plural of index. That's all it is. So when you see your, math textbook, you see a chapter on indices. What in the world is it? It's really the plural of index. Ooh, some disturbances there. Okay, all right. Okay, now what is index then? All right, so you know indices. Indices is really the plural of index. So what is index? Now, index is kind of a short form. Every time you see this word index, think of short form. And you know what kind of short form? So for example, you have 2 times 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 2. Now, instead of writing like this, you write it in this form, 2 to the power of 10. So you can see that this index here to the power of 10 is kind of like a short form. Or if you don't like the term short form, if you find it too casual, you can call it sort of an abbreviation. So an index is a kind of an abbreviation. All right, very, very, very simple. When you're using indices, you're using abbreviations. All right. So indexes are really, really easy. Indices are really, really easy because it's governed by a bunch of rules, all right? A bunch of rules. And I will go through these rules with you. Now, the secret to mastering indices is this. The secret to mastering indices is to master its rules, all right? Once you have the rules mastered, you are okay. You are all right. You are ready to go. So the first rule is this. A to the power of n times a to the power of m equals to a to the power of n plus m. This is one of the most common rules, all right? And it's a very, very, very important rule. Okay, so, master these rules because the key to mastering indices, the chapter called indices, is, the mastery of its rules. The moment you become very comfortable with the rules, you will see that it all works out nicely. All right, so this is the first one, and this is the second one. All right, the second one is a to the power of n. Instead of times, it's now divide a to the power of m equals to the a to the power of n minus m. If it's a times, it's a plus. If it's a divide, it's a minus. Very simple. All right, a to the power of 0, anything to the power of 0, anything. A can stand for anything. All right, maybe that's why it's a for anything. Anything to the power of 0 is 1. All right, so a to the power of n and the whole thing to the power of m is simply a to the power of m times n. Very, very simple. All right, you can also swap it, n on the outside and m on the inside. You can swap this, all right, or you can just multiply it out. All right, the fifth rule is this, a to the power of m times b to the power of m. Now you see that the base is different, but the index is the same. The index is the same, but m, but the base is a and b. You will see that it's just ab to the power of m. And the last one on this side is a to the power of m divided by b to the power of m. Again, you see that the index is the same, but the base is different. It's just a over b to the power of m. All right, and these are some of a to the power of minus 1 is simply equals to 1 over a. A to the power of minus m simply equals to 1 over a to the power of m. All right, a to the power of half is the square root of a. That's what it means. A to the power of 1 over m equals to the mth root of a. So a to the power of 1 over 3 is the cube root of a. And the last one, this is the final one, all right? A to the power of n divided by m equals to this or that, right? Too long to say, so just look at it, all right? So here, if you master this bunch of rules, I don't know how many there are here, maybe about 10 or 11, this bunch of rules, you will see that you've got the chapter called indices all worked out. Very, very simple. So let's, okay, other than the rules, what you really need to memorize. You really, really need to memorize this, because if you memorize this, it will become so much easier. All right. Okay. And you don't have to sit down to memorize it. As long as you do many questions, you will see that it comes to you automatically. And so one of the first things that you need to know is the 2 to the power of table. So 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and so on and so forth. Know for 2 to the power of something, know it to the power of 10. Know this, because it's going to come in really useful. When we work on the questions later, you will see that knowing this at the tip of your fingers is so useful. Now, other than that, know also this for 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27. Memorize this. Do so many questions till it becomes a part of you. All right, and also 5 to the power of 1 is 5, 5 to the power of 2 is 25, 5 to the power of 3 is 125, 5 to the power of 4 is 625, 5 to the power of 5 is 3,125, 3125. All right, know it for 7 as well. All right, 7 to the power of 3 is 343, 7 to the power of 4 is 2401. Now, did I memorize this? I didn't. I got all this by doing lots and lots of questions. All right. And last one, at your fingertips, know these. 13 to the power of 2, 14 to the power of 2, 15 to the power of 2, up to 20 to the power of 2. It will come in useful. Believe me, you will thank me. So let's summarize what we have done right now, up to now. I've told you what's important. If you want to master indices, the first thing that you're going to master are the rules. And we're going to master them not by meditating upon them. We're going to master them by doing lots and lots and lots and lots of questions. And remember, my sessions are full of examples, because I believe in examples. Because when I was doing math, when I was a math student, I relied on a lot of examples. And that's why when I'm teaching you now, I'm giving you lots of examples. So these rules, I'm not going to like concentrate on each one of them, but I'm going to show you how it's applied in questions. All right. So the first thing to master is rules. And the second thing, if you want to really do well, is 2 to the power of table, 3 to the power of, 5 to the power of, 7 to the power of, and square tables. All right. If you have this in your fingertips, believe me, you will be really, really, really good at indices. All right. You cannot be but good. Okay, so let's start off by doing a few basic questions. All right, we're going to have lots of questions, because indices questions tend to be pretty short. They tend to be pretty short. If you're going on and on and on about a question, something has probably gone wrong. All right, so if you're asked this question, 3 to the power of 6 times 3 to the power of 5, 3 to the power of 6 times 3 to the power of 5, and you can write it out. 3 to the power of 6 is 3 times 3 times 3 times 3 times 3 times 3 times 3 to the power of 5, 3 times 3 times 3 times 3 times 3. You can write it out, and it's not wrong. It's absolutely correct. All right, and when you look at it, it's really 3 times to the power of 11. All right, because there are 11 3's here. All right, but if you remember this rule, this is one of the rules we covered just now. In fact, this was the first rule we covered. You will see that 3 to the power of 6 times 3 to the power of 5 is simply 3 to the power of 6 plus 5. How do I know this? Because of this rule. And you would agree that doing this is a lot more error prone. What's wrong with this? There's nothing wrong with this. This is correct. This first way of doing is correct, except that it takes more time and it's a lot more error prone. All right. And in exams, you don't want to be error prone. You want to be free of errors. All right. So when you use this rule, it's just 3 to the power of 6 times 3 to the power of 5. Same question. I'm using the rule now. 6 plus 5 equals to 11. So it's 3 to the power of 11. And you can see that from this, my knowledge of this rule has enabled me to simplify it to just this. Same question with the same answer. All right. But a lot shorter, a lot safer. All right. You will get the answer correct. Now let's do some more. 8 to the power of 3 times 8 to the power of 4. And applying the rule, you see that it's just 8 to the power of 3 plus 4, 8 to the power of 7. All right. 2 to the power of 3 times 2 to the power of 7 is 2 to the power of 3 plus. Why is it plus? Because it's a times. All right. Times, so you just add the exponents. Okay. Now, so this is times again, 2 to the power of 3 times 10, 2 to the power of 7. Again, you add the exponents, so 2 to the power of 10. All right. 3 to the power of 7 times 3 to the power of 9 is 3 to the power of 7 plus 9. Again, why is it plus? It's a plus because you are multiplying these two numbers, right? And 7 plus 9 is just 16. Now imagine you have to write this out in full like just now, like in this manner. All right, it will be very, very error prone. Okay, now fourth question here, 2 to the power of 4 times 2 to the power of 6. So it's 2 to the power of 4 plus 6. Again, you get 2 to the power of 10. Now, here you have the base of 8, base of 2, base of 3, base of 2. Now, the good news is this, the base doesn't have to be a number. The base can be a letter. So here is the same, but you know, the questions on this side, on the right side, I'm going to do some more questions, but I'm going to use some letter bases. So x to the power of 4 times x to the power of 3. The base here is x, the index is 4. The base here is x, the index is 3. And the method is the same. All right, as long as you have the same base, x and x, it's the same base. Now add up the exponents if you're multiplying. So x to the power of 4 times x to the power of 3 is x to the power of 4 plus 3. So x to the power of 7. All right, all you have to ensure is that the base, the two bases are exactly the same. 8 and 8, 2 and 2, 3 and 3, 2 and 2. Now here it's x and x. They must be the same. They must match perfectly. All right. Now same, you have y to the power of 5 times y to the power of 5 times y to the power of 2 equals to y to the power of 5 plus 2. All right, you're adding because you're adding the exponents because the bases are the same and you're multiplying these two numbers. And that equals to y to the power of 7. All right, same, p to the power of 3 times p. Suspicious. What's this p here? This p here is p to the power of 1. All right, every time it's 1 to the power of 1, you don't have to explicitly put down the 1. In fact, it will be strange to put down that 1. So here, this is p to the power of 3 times p to the power of 1. And you get p to the power of 3 plus 1. The base is the same, add up, you're multiplying the numbers, so add up the exponents. So that's p to the power of 4. Q to the power of 7 times q to the power of minus 3. Hey, there's a minus 3 here. Does it still work? Yes, it still works. So here you have q to the power of 7. And since the bases are the same q and you are multiplying them, just add up the two powers. So 7 plus, and this is a minus 3, but you still add it. 7 plus minus 3, and 7 plus minus 3 is a 4. So that's how you apply the formula. All right. Now, you know, in any book, in the textbook that you're using, there's going to be a lot of these simple questions. Now, go through the simple questions one by one. I encourage you to go through the simple questions because they are the questions that will lay the foundation for the more difficult ones. Many of the students, you know, rush on to do the difficult ones and they neglect the simple ones, not realizing that they are not laying a proper foundation. All right. So go through the simple ones. This may look very simple, but you know, for foundation laying purposes, it's really, really very good. So now we've done with the multiplication. Now I'll show you the division. All right, and 3 to the power of 7 divided by 3 to the power of 4 is really simple. It's 3 to the power of 7 minus 4. This is minus 4. All right. So why is it minus? Because your bases are the same. So and it's a divide. So it's 7 minus 4. So you get 3 to the power of 3. That's all. All right, 4 to the power of 7 divided by 4 to the power of 2. That's 4 to the power of 7 minus 2 or equal to 4 to the power of 5. Again, it looks simple. The questions are not, they don't just look simple, they are simple. All right, but do it. All right, so 6 to the power of 5 divided by 6 to the power of 3 is 6 to the power of 5 minus 3 or 6 to the power of 2. This is a little bit tricky. So 11 to the power of 7 over 2. Fractional index. It's fractional index 7 over 2 divided by 11 to the power of 2. So what do? You do the same thing. It's 11 to the power of 7 over 2 minus 2. Divide, so minus 2. All right, and that's 7 over 2 minus 4 over 2, and that's 3 over 2. And if you don't want to write, if you don't want to leave it in this form, and you can also write it in this way. All right, so it's a square root of 11 and the whole thing to the power of 3. No problems. And the same as the multiplication, it also works when your base is in symbol form. So it need not be 3, 4, and 6, and 11. Here the bases are 3, 4, 6, and 11. It need not be numbers. It can be a letter. And so here the letter is x. As long as your base is similar, you are doing a division. subtract the indices. All right. So here is x to the power 5 divided by x to the power 2. That's x to the power 5 minus 2, x to the power 3. Same, y to the power 7 divided by y to the power 3. It's a division, so minus, subtract your indices. All right, 7 minus 3, y to the power 4. Now, n to the power of 10 divided by n to the power 4 equals to n to the power of 10 minus 4, n to the power of 6. All right, and the last one here, z to the power of 6 divided by z to the power of 3 is a division, so you subtract 6 minus 3 equals to z to the power of 3. So it's very, very simple. All right, now another rule. What happens if you have x to the power of 3 and the whole thing to the power of 2? And what this means, what does this really mean? All right, if you have a to the power of 2, it means a times a. If you have b to the power of 2, it means b times b. If you have c to the power of 2, that means c times c. If you have x cubed to the power of 2, that means x cubed plus times x cubed. That's what it means. All right, and of course you can expand it in this way, and you can also like, okay, since it's x to the cube times x cubed, it's just x 3 plus 3 to the power of 3 plus 3 equals to x to the power of 6. But if you remember this rule, what you have to do is just x to the power of 3 and the whole thing taken to the power of 2. What you need to do is just x 3 times 2 and x 6. And again, I stress, this gives you speed, this gives you elegance, this gives you, safety. All right, it's a lot less error prone. All right, so know your rules because you'll be able to do things in a very, very much faster way. And in every mathematics exam, there's always an element of speed. Believe me, I've been teaching for the last 29 years. In every mathematics examination, there is always an element of speed. All right, examiners are always interested in, in testing whether the quickness of mind of the candidate. All right, so, know your rules. So here, what about this? So you have y to the power of 3 and the whole thing taken to the power of minus 2. Same. Use this rule here. It's exactly the same. So here 3 times minus 2 is minus 6. And you could leave it like that. You will get it correct. But you could also express it like that. 1 over y equals to 6. All right. Z to the power of minus 1 and the whole thing to the power of minus 3. And that's minus 1 times minus 3. And that's z to the power of 3. Simple. All right. So you can see how fast this is. Now 1 over w squared and the whole thing to the power of minus 3. And 1 over w squared is w to the power of minus 2. All right, make this switch and you will see that immediately it's so easy. It's just minus 2 times minus 3, you get w to the power of 6. Do it systematically because I stress that you really need to be doing it systematically. Because mathematics, a lot of mathematics is clearing up, is housekeeping, is getting things tidy. And if you look at all my videos, you will see that all the questions, all I'm doing is just to tidy things up. All right, don't rush, just tidy things up one step at a time. All right, let's go on. So u to the power of 3 over 2 times u to the power of half, that's, because it's multiplication, you just add up the indices and you get 4 over 2 or just a 2 there. All right, v to the power of 4, 3 times v to the power of 1 over 3 is a multiplication. The bases are the same. Just add it up and you get v to the power of 5 over 3, or you can express it in this format if you want to. These are both correct. No problems at all. Both are correct. Okay, x to the power of 3 over 2 divided by x to the power of half. That's simple. X to the power of 3 over 2 minus half, because that's a divide there. X to the power of 2 over 2 or x to the power of 1. And as I've stated earlier, it's very strange to have x to the power of 1. Just have an x there. Last one here, q to the power of 1/4 to the power of 0. Anything to the power of 0. Anything to the power of 0 is 1. All right. Now let's go on some more before we're getting into more difficult questions in a while. All right. But let's look at some of the simpler ones. Okay. Let's lay our foundations first. I stress, for mathematics, laying foundations is absolutely critical. So a times b to the power of 4. You have a times b taken to the power of 4 together. So here, use this. This is called a raised dot. All right, and this is used to signify multiplication. So it's A multiplied by B and together taken to the power of 4. So the 4 applies to A and the 4 applies to B as well. It applies to A and applies to B. So that's A to the power of 4, B to the power of 4. Remove that and you get this. Again, it's a matter of being systematic, being step by step, and being, tidying things up. So xy to the power of 3, same. Split it up, x times y. This raised dot here means multiply times, right? So it's the 3 here is applied to x, it's applied to y. So x to the power of 3 times y to the power of 3. And then after that, remove it, x cubed, y cubed. All right, 2a to the power of 3. A little bit strange because you have a number. The number is 2. Same, although it's a number, nothing, no difference. It's 2 times a. 2a means 2 times a. And again, you have 2 to the power of 3 and then a to the power of 3. So 2 to the power of 3 is simply 8. Remember, if you got your 2 to the power of table, 2 to the power of 1 is 2, to the power of 2 is 4, to the power of 3 is 8, to the power of 4 is 16, to the power of 5 is 32. All these things will be very easy. And that's why I stress it. Many teachers today, they avoid saying the word memorize. But I find that there's nothing wrong with it. A lot of things are automatic to me because I memorized them. All right. And then how did I memorize them? Did I start chanting them or what? Or copying them down? No, I memorized them by doing lots and lots and lots of questions. And, over time, it just came to me. So 3y to the power of 4, same. 3 to the power of 4, y to the power of 4. And 3 to the power of 4 is 81. All right. If you didn't know this, you have to bring out your calculator, 3 to the power of 4. Again, error prone. Again, you're wasting time. 3 to the power of 4 immediately is 81. 3 to the power of 5 is 243. And so on and so forth. Get it all in your head. Mn squared to the power of 5 is simply m to the power of 5. And this is n squared. So n squared gets its own to the power of 5. All right. So this 5 here is applied to both. Right. So n squared to the power of 5. So you have m to the power of 5, n to the power of 10. Simple. All right. So what about this? 3 divided by 3a squared. Anything squared is that times that. So 3a squared is 3a times 3a. That's what it is. So cancel that 3, cancel that 3. You have 1 over 3a squared. Simple. Whoa, this looks kind of tough, huh? All right. But again, it's simple. So it's x to the power of half times x to the power of minus 3 over 2. And the whole thing is divided by x squared. So let's, the top is messier. Go for the, when you attempt a question like that, go for the part that's messiest, that needs most clearing up. All right. So what you do is this, since it's a multiplication, you add it out together. So it's half minus 3 over 2. So we are getting the numerator in order first. Forget about the denominator. You can see that the denominator stays x to the power of 2, x to the power of 2, x squared all throughout. All right, because we are not bothering with it first. We are trying to settle the numerator. So that half minus 3 over 2 gives you minus 1. And once you have done that, then you will see that this is a division. It's x minus 1 minus 2. Why is it minus 2? Because it's a division. It's at the bottom. It's x to the power of minus 1 divided by x to the power of 2. Right? This is a divided by. So it's minus 2. So that's x to the power of minus 3. And that's 1 over x cubed. Simple. All right. Just be systematic. Don't skip steps. Don't panic. Another one that looks quite similar. You have y to the power of minus 1 over 3. After that, you have y multiplied by y to the power of 4 over 3. All right, divided by y. Again, go for the part that is most messy. And the part that's most messy is the numerator. So we're going to settle the numerator first. We're going to take care of the numerator first. And that's y to the power of 1 over 3 plus 4 over 3. All right, minus 1 over 3 plus 4 over 3 because it's a multiplication here. So that gives you y to the power of 1. All right, and divided by y to the power of 1 again. All right, so that's y, 1 minus 1, y to the power of 0, and that gives you 1. All right, you could have just canceled it and said 1. All right, but I wanted to do this to show you, it's, since we are on the topic of indices, I wanted to show you that even if you do it not by the cancellation way, by the method of indices, you would end up with a 1. Okay, whoa, what's this? All right, this is x half, x to the power of half, right? Multiplied by this bracket, the contents of this bracket, which is x to the power of half plus x to the power of minus half. All right, and again, you spread it out. I call it spreading it out. So this x to the power of half is multiplied by x to the power of half, and that's here. And this x to the power of half is multiplied by x to the power of minus half, and that goes on here. And that's a plus sign, so retain the plus sign there. Plus, retain the plus. So multiply this and multiply that. Retain the plus sign. All right, and when you multiply this out, it's half plus half. So that's x to the power of 1. X to the power of 1 is simply x. Here, it's x to the power of half plus minus half, and that gives you x to the power of 0. So the x power of 0 equals to just 1. Retain the plus sign. So again, clarity of mind, go and do your spring cleaning. This looks challenging, all right? So let's see what we do. Again, multiply this inside. So that's m to the power of minus 3/4 times m to the power of 7/4. There's a minus sign here, so we retain the minus sign there. Retain it, all right? Don't change. There's no reason to change. So again, this is minus 3, m to the power of minus 3/4 times m to the power of minus 1/4. All right, so multiply this minus multiplication of that. All right, that's what we have here. And it's very simple because minus 3/4 plus 7/4, we have to add because it's multiplication. So 7/4 minus 3/4 is 1. It's 4/4, that's 1. So that gives you a 1. Minus 3/4 plus minus 1/4 is minus 1. So you have a minus sign from there. And when you add that up, you get a minus 1. So if you don't like the look of this, just have it as m minus 1/m. This or this, 100 marks, full. All right, you have done your work. All right, let's get on to some questions that are slightly more difficult. Simplify that. And again, it looks tough. You have a mixture of numbers and A and B. You have a mixture of three things, numbers and an A variable and another one called B. So you just do it systematically. All right, handle the numbers here, 15/3. So handle the numbers first, handle the A and handle the B. That's all you have to do. There's nothing more to it than this. So 15 divided by 3 is a 5, so put it down there. A, 3 minus 2. Why is it minus? Because it's a division, so 3 minus 2. And that's B, 7 minus 3, because again, it's a division. A line like that means a division. So again, do your spring cleaning. 3 minus 2 is a 1. 7 minus 3 is a 4. And remove your raised dot. Right? This is called a raised dot. So remove it and you have your 5a b to the power of 4. Right? Simplify the following. Again, the 3 applies to the number. The 3 applies to the 3 here. The index of 3 applies to the number. It applies to x squared. It applies to y cubed. It applies to z to the power of 4. It applies to each one. So just be systematic. Don't rush. Right? So 3 applies to the number 3. So 3 to the power of 3. And that's 27. 3 applies to x squared. So it's x squared to the power of 3. 3 applies to y cubed. So that's y cubed to the power of 3. 3 applies to z to the power of 4. So that's z to the power of 4. The whole thing to the power of 3. And again, just do it systematically. 3 to the power of 3 is 27. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. Get rid of the raised dots and you've got it. Okay, always do it step by step. Don't skip steps. All right, every step is important. As long as it contributes to your understanding, it's important. All right, don't skip steps yet. So here, simplify fully. Again, the 5 is applied to the 2, the 5 is applied to the x, and the 5 here is applied to the y cube. It's applied to every single one of them. So you have 2 to the power of 5, x to the power of 5, and y cube, the whole thing to the power of 5. And 2 to the power of 5 is 32. Again, remember, if you have got it in your head, you can just put 32 down. You have to be that sure. You have got to be that confident. All right, if you've got to bring out your calculator, hit the buttons, you wasted 5 seconds. And 5 seconds can mean everything. All right, so x to the power of 5 here, 3 times 5 is a 15. So remove the raised dots and you've got 32, x to the power of 5, y to the power of 15. Simple. All right, now this I got all these questions are from the internet because I'm on there's circuit breaker in Singapore. I can't get access to my office, and that means I can't get access to my books. All right, so all these questions are really from the internet. All right, I've got it from all over the place. Now, so simplify this. We're gonna do both of them. All right, so you have x squared y to the power of -3, x to the power of -4, y to the power of 5, and the whole thing, to the power of half, square root of the whole thing. Now, what do you do, right? There's a mixture of x and y. Handle them systematically separately, right? So you have a 2 here and you have a -4. X to the power of x squared divided by x to the power of -4. And when you divide, it's a minus, right? So it's 2 minus -4. All right, 2 minus. This minus is because you are dividing. And this -4 comes right from here. All right, and y -3 is from here. And why do you -5? Because you are dividing by y to the power of 5. So handle it separately and put a raised dot here to separate things and to make things really clear. All right, I love this raised dot because it helps me to, separate things into neat compartments. I love it. I really, really like it. I use it a lot. Okay, so 2 minus -4 is 6. -3 and -5 is -8. And half applies to both, right? Half applies to both. So 6 times half is a 3, and -8 times half is a -4. So you can have that, or if you want to, you can express it in this form. Either way is fine. If you stop at this step, it's also correct. All right, so let's look at the second one. All right, let's look at the second one. The second one is this. And again, the first step is really to change it into these numbers. This is very, very hard to handle. These are called radicals. All right, and it's very hard to handle radicals, right? So change them to indices. So that's 3/2. And this is 1/4. And this is again, this is 2/3. All right, and once you have this, ask yourself, which is the messier part? Is it the numerator or is it the denominator? Which part I need to work on? And again, you will see that the denominator is the one, the downstairs is the one that you have to work on first because it's messier, right? So it's because you're multiplying, it's just 1/4 plus 2/3. And if you take your calculator, 1/4 plus 2/3, you will get this numerator stays the same. I'm just putting it down here. All right, so it's 1/4 plus 2/3. All right, a to the power of 1/4 plus 2/3, and you get this gets brought down, and that's 1/4 plus 2/3 is 11/12. All right, do it with your calculator. It's 11/12. All right, and once you have this, it's just simply a to the power of 3/2 minus 11/12. Why is it minus? Because it's a divide here. All right, and again, bring out your calculator, punch, punch it, and you will get 7/12. This is 18/12 actually. 3/2 is 18/12. 18/12 minus 11/12 is 7/12. You can leave it as this, or if you want to, you can express it in this form. Right? That's both are perfect. Both are correct. Okay. I've done this because it started off, being expressed in this way, and so I end up expressing it in the same format. All right. It's not necessary. Okay, let's look at some questions. All these are from the internet, all right? And this looks scary, man. All right, what's happening here? Given that this stuff, evaluate this. All right, and really, this looks complicated and this looks simple. All right, forget about the math first. Just look at it as a human being and you will see that this is complicated, this is simple. And so what you're doing here is a process of simplification. What you're doing is clearing up. All right, lots of clearing up here. All right, so let's start clearing up this mess and try to make it this neat number, this neat expression here, right? So here you start off with this, okay, because that's what the question gives you, and you will see that there are two things here. There are numbers, and they are just like numbers like 40. 40 is a number, it's a beautiful number. Wonderful. 5 times 8, 5 times 2 to the power of 3. All right, it's a very nice number. And you have also numbers that are raised to the power of x, right? Like 5, 2 minus x. You have a mixture of two things here. And that's what you've got to realize at this stage. You've got a mixture of pure numbers like 40 and numbers that are kind of adulterated. They've been mixed, all right, with x, all right, with the index of x. So here, what we're going to do is we're going to tidy up first by disentangling these two. The 40 is perfect. 40 is nothing you can do with it. So leave that. Now 2 to the power of 2x minus 4. So that has to be 2 to the power of 2x divided by 2 to the power of 4. We are untangling this. We are untying the knot. And we untie the knots here too. It's very knotty, all right? K-N-O-T-T-Y, knotty, all right? Not naughty as in a bad boy or bad girl. Huh? Naughty as in is in knots. All right. So we have to untie the knot. So it's 5 to the power of 2 divided by 5 to the power of x. So after untying the knots, you will see very clearly that 40 is a number. 5 to the power of 2 is 25. It's also a number. 2 to the power of 4 is 16. That's also a number. So you have 3 numbers here. And there are 2 terms here that involve x. 3 terms, 2 to the power of 4, 40, and 5 to the power of 2 here that does not involve x, and 2 terms here that involve x. And now you use your, kind of like tidying up skills and separate them. And what we have done here is just to separate, on the left side, you have terms with an x. On the right side, you have terms that are without an x. That's all you're doing. All right, wonderful. So 2 to the power of 4, just bring that up. 40, bring that down, and you have this here. All right, and after this is all a matter of applying the rules of indices. So here 2x. Now you will see that this number here, it's to the power of x. There's no 2x up there. We've somehow got to, again, untangle the knot again. So we've got to get rid of this 2 here. And how are we going to do that? We're going to do that by saying it's 2 to the power of 2, the whole thing to the power of x. All right, and why are we doing this? At every step, ask, why do you do this? You're doing this because you want to reach this, 20 to the power of x. There's no 2x there. There's no half x. There's no 3x. There's just x. So we've got to leave just x there. All right, and what I've done here is 5 to the power of 2 is 25. 2 to the power of 4 is 16. This is easy stuff. All right, so 2 to the power of 2 to the power of 2 to the power of 2, the whole thing to the power of x equals to 4 to the power of x, and that's 5 to the power of x, and that's 400 divided by 40. And we've got it already. So here, because the index is the same, x and x, we can multiply the bases together, and that's 4 times 5, and that gives us 20. All right, why are we multiplying? Because it nicely gives us 20 to the power of x, and 400 divided by 40 is a 10. So there you have it. Evaluate 20x. 20x has a value of 10. Wonderful, right? Evaluate 20x. What's the value of 20x? 20 to the power of x. 20 to the power of x has a value of 10. That's all you need to do. That's it. Answer. Right, now show that, wow, that looks scary. Show that this whole messy stuff is equals to this neat stuff. Messy, neat. All right, so start with that. Start with the messy stuff and start untangling the knots. All right, so that one here, that's 5 to the power of 1, or 5 to the power of n times 5 to the power of 1, because it's a plus sign. So here's multiply, and I'm using a raised dot here again. And so I'm leaving this as it is because it's nice. All right, and that's 5n divided by 5 to the power of 2. Why divided by 5 to the power of 2? Because it's a minus 2. And I'm leaving that. That's beautiful. Okay. And once I do that, you'll see that 5 to the power of 1 is simply 5. 1 over 5 to the power of 2 is 1 over 25. So I'm simply, just multiplying this. 5 to the power of 1 is 5. 5 to the power of 2 is, this is 1 over 25 here. All right. And this is 4. And that's a 1. I'm adding this for clarity. All right, I need not add this, but I'm adding this for clarity. So 5 of that minus 4 of that is simply 1 of that. 5 of this minus 4 of this is just 5 to the power of n. and you have 1 over 25 plus 25 over 25. This one here is 25 over 25. So that's 26 over 25, 5 to the power of n. All right. So again, it works out beautifully because your 5n and 5 to the power of n and 5 to the power of n, they cancel out. This cancels with that, leaving you with this 1 over 26 divided by 25, because that cancels out with that. And this is simply 25 over 26, whatever we wanted. All right. So again, calm yourself down, be systematic, and untangle the knotty parts. All right. A lot of knots, just untangle them one by one. Now express this very messy stuff, all right, this messy stuff, express it in the form of y to the power of n, where n is an integer. Z here is a mathematical shorthand, if you want to, all right, shorthand for integers. So Z, or sometimes it's a little fancier with this double lines, all right. Now this Z here denotes integers, all right, and integers can be, they are whole numbers. They can be positive integers, they can be negative integers, all right. They can be positive or negative, but they have to be whole numbers, like 5 or -7, all right, -7. That's also okay. Now, let me. I've just been told that I don't have enough energy. I don't have enough. All right. So let me adjust my computer here. Okay. All right. So here, okay, I do have. I'm being charged now. Okay, or my computer is being charged now. I've been charged earlier with dinner. Now, so I'm just repeating this here. All right, and look, 16 is 4 to the power of 2. 64 is 4 to the power of 3. And so here you can reduce everything to a bunch of 4 to the power of something. All right, so 16 to the power of half, that is the square root of 16, and the square root of 16 is simply 4. Square root of 16 is 4. And 64 is 4 to the power of 3. Remember, just memorize this so that you don't have to start fiddling around. You have it at your fingertips. It's so convenient. It's so convenient. All right. So here you have 4 to the power of 3 and the whole thing to the power of 203. All right. So the only thing I've changed is 16 a square. I've squared 16 to get 4, and I've changed 64 to 4 to the power of 3. And what's happened here is that everything is 4 to the power of something. All right. And that makes things easier. So you have 4 to the power of 2. That is 4 to the power of 1. All right. I'm stating that explicitly. 3 times 2 to the power of 3 is 2. So that's 4 to the power of 2. And that's multiplied by 4 to the power of 3. All right. And of course, 2 plus 1 is a 3. 2 plus 3 is a 5. And that is 4 to the power of 3 minus 5. And that's 4 to the power of minus 2. And why am I leaving this? I'm not saying 1 over 4 to the power of 2. I'm leaving this because it says expressed in this whole lot in the form of 4 to the power of n. And I've reached it. I have reached it, 4 to the power of n. And the n is therefore minus 2. So you might like the final statement here that says that n has the value of minus 2. All right, now by using the substitution u equals to 5 to the power of x, solve this stuff. All right, so again, it's messy here. Let's repeat that over here. And let's do this. So 5 to the power of x divided by 5 to the power of 1. Divided by, because it's minus 1. 5 to the power of 2 divided by 5 to the power of x. Divided by 5 to the power of x because of the minus x here. Equals to 6. Nothing much you can do over here. Nothing much. Now it says, what we've done here is this. We have enabled the substitution to happen. All right, what have we done? What have we achieved? We have converted this to a form which enables this substitution to be performed smoothly. You cannot substitute u equals to 5 to the power of x here. It's really, really, really impossible. But once I transform this, it's easy. That 5 to the power of x is u, 5 to the power of x is u. All right, so, at every stage, be aware of what you are doing. Everything that you do must lead you, must steer you in the direction of the solution. It must not steer you away, all right? So what we have done here is we have enabled this substitution to take place. It says by using the substitution, you have to use a substitution. So we are enabling it, we are substituting, and you know, the piece of chicken in between the teeth, I always use that metaphor because it's very irritating, is this 5 and this u. It needs to be somehow cleared up. And we clear this up by multiplying throughout the whole equation, left side and right side, by 5u. We're going to multiply the whole equation by 5u. Why? Because you have a 5 here and you have a u here. So we're going to multiply by 5u. And when we do that, that's what we get. When you multiply this by 5u, you get u squared. When you multiply this by 5u, you get 125. When you multiply this by 5u, you get 30u. And, you know, this is just a quadratic equation, all right? Convert it, you know, rearrange it to its standard form, factorize it. And once you have factorized it, you see it's u equals to 25, u equals to 5, all right? But the solution doesn't say solve for the value of u, it says solve this. And when the question says solve this, what the question means is solve for the value of x, all right? U is something like an intermediate value. It's like a transit point. It's like going from Singapore to London, but transiting in Dubai or in Doha. So U is like Dubai, all right? So it's a transit point. We've got to take 5 to the power of x equals to 25, and that gives you x equals to 2. 5 to the power of x equals to 5, and that gives you x equals to 1. Simple. All right, so you've got it solved already. X equals to 2 or x equals to 1. Right? Okay, another question. Express the equation, this messy thing, as a quadratic equation in 3x and solve the equation for x. So let's just reproduce this, and you can see very clearly that 9 is 3 squared. What's 9? 9 is 3 squared. And that's what we go for here. 9, we replace it with 3 squared. And 3x to the power of x minus 1, we have 3x divided by 3 to the power of 1. The 3 here at the bottom comes from the minus 1 here. All right, and once we have done this, look at this magic here. We're going to interchange the two. And we interchange the two like that. All right, so what's happening here is this x goes in and the 2 comes out. We have interchanged the 2. All right, and why are we doing it? Again, be aware of why you are doing this. Why? Why we are doing this is because we want to get a bunch of 3 to the power of x. Why? Because it says express this equation as a quadratic equation in 3 to the power of x. And so we want to end up with a whole, bunch of 3 to the power of x's all over the place. All right, and we've managed to do that here and here. And now what we can do is, taking a leaf from this question here, it says u equals to 5 to the power of x. I'm copying this. All right, I'm learning from this question. I'm going to say u is 3 to the power of x. So instead of 3 to the power of x, I'm just going to put a u here. All right, and after that, you have 3 to the power of x, I'm going to put a u here. All right, and this doesn't look natural, so I'm going to just remove the brackets. And once I remove a bracket, it becomes like that. Again, this is a quadratic equation. I can factor this. All right, I can factor this out. Okay, and when I factor this out, it becomes like this, which means u equals to 7 over 2. From here, u equals to 7 over 2. And from here, u equals to 9. All right, I've skipped a step here because of the space I have in this slide. Okay, but you don't skip a step. U equals to 7 over 2, u equals to 9. And remember again, 7 over 2, u is not what we are after. We are after x. U is Dubai. We want to go to London. All right, we don't want to transit in Dubai, fall asleep, and the plane takes off without us. All right, we want London, and London is x. So here we have got to take the 3x equals to 7 over 2 and 3x, and that means that x equals to log base 3 of 7 over 2. That's what it means. All right, that's what it means. Okay, and we'll deal with this in a while. All right, I'll deal with this in a while, but let's go on to the other one. 3 to the power of x equals to 9, and x therefore is definitely a 2. 3 to the power of 2 is 9. So we're left with this. Now, how do we handle this? So here it's a log base 3 of 7 over 2. So log base 3 of 7 over 2 is simply log base 10 of 7 over 2 divided by log base 10 of 3. We haven't done logarithms yet. I plan to do it like 2 weeks from now. All right, but take it from me just now. All right, for now. We have not done it, but okay, I'm just using it without having taught it yet. And once you key in this into your calculator, you have 1.1403. That's it. Simple. Very, very simple. So your values, your solutions are x equals to 2 and x equals to 1.14. Solved. Okay, we go on to another type of question, and this is a simultaneous equation. I like this. It's a simultaneous equations. And you see that you have two equations there. And these two equations are pretty complicated, pretty complicated. All right, pretty complicated. But, right off the bat, you should see that 16 is 2 to the power of 4. So 2 to the power of 4. 4 to the power of 4 is 2 to the power of 2. 0.5 is 2 to the power of minus 1. And that's it. Half, this is half, equals to 2 to the power of minus 1. 4 is 2 to the power of 2. And 16 is 2 to the power of 4. So you really once you memorize these things, you're really able to see it very quickly. All of this, it looks very complicated, but they are something to the to the base too. You have a common base. Remember, indices is about either a common base or a common index. This is all you really is. This is the magic of indices. You either go for a common base or you go for a common index. All right. So here immediately you spot a common base, and the common base is 2. Now here there's a 1, and this is really so. For logarithms, you want consistency. You want log to the power of log base 4, log base 4, and you have a log base 4 here too. You don't have 1, so you have to convert this into a log base 4, and you can, because you know that 1 is 4, log base 4 of 4. So you've got things figured out, and let's start. So let's start with this on the left and this one on the right. Okay, so this will be on the left and that will be on the right. So let's start with this. Simple. So that's 1 is half. So that's 2 to the power of minus 1. All right, and the x stays there. And that's 2 to the power of 2, and that's 2 to the power of 6. And it looks beautiful now because we have everything to the base of 2. It's beautiful, it's wonderful. All right, and minus 1 times x is minus x. 2 times 3y is 6y. 2 to the power of 4 is 4. All right, 2 to the power of 4, 2 to the power of 4. Same, just retain it. Now, once you have this is multiplication. This is 2 to the power of minus x times 2 to the power of 6y. So because it's multiplication, you add this up. 6y minus x. Retain this. And because your bases are now the same, you can equate your indices. 6y minus x equals to 4. And once you have done that, you can say that 6y minus 4 equals to x. Bring that, and that becomes a minus 4. Bring that over, that becomes an x. Now, what have you done? What's this all about? Now, this is really preparatory work. You're preparing the ground. Later on the right side, you will have to replace something with x. Replace your y with x, and you have an expression for x already. You have already prepared yourself. X equals to 6y minus 4. Anytime I have x, I can replace it with 6y minus 1. That's what you are doing. You are preparing the ground so that anytime in the future when you see x, you can replace it with 6y minus 4. So let's go on to the right side. You see this, and as I told you, 1 is log to the base 4 of 4. This is very, very important because this equation can't be worked on as it is, all right? Because it's inconsistent. You have log to the base of 4, log base 4, and here you have a pure number. Logarithms, we will see in 2 weeks' time, is all about consistency. All right, so here you make it consistent. And after that, because this is a plus sign, you multiply this together, 2x times x plus 3y. All right, and just leave that. And because that's log 4 of this and log base 4 of that, you can really equate them. This equals to that. And after that, you multiply them out. 2x times x is 2x squared. 2x times 3y is 6xy equals to 4. And You see it now. I hope you see it. Everywhere you have x, put in a 6y minus 4. So here, this is where you have x. That's where you have x again. Now put in your 6y minus 4, 6y minus 4. That's where this comes in useful. It's superb. It's so important that you have this ready. Get this prepared, put it by the side, get it ready. When you need it here, put it in. All right, so here you have this. This is just coming from here. All right, there's a 4 there. All right, so multiply this out. So you have a 36y squared plus 16, and 2 times 6 is 12, times minus 4 is minus 48. So you have this 6 times 6y squared, y is brought in, and 4y equals to 4. And now you have 72 minus 96, 32. Multiply it out, multiply this out. 6 times 6 is 36, 6 times minus 4 is minus 24, and that 4 stays. Now, it's nice because this is something familiar. This is a quadratic equation. So you have 72 plus 36, 72 plus 36 is 108. Minus 96 minus 24 is 100 and minus 120. 32 minus 4 is 28. And this is begging to be divided by 4. All right, this is begging to be divided by 4. So when you divide this by 4, you divide everything by 4. 108 divided by 4 is 27. 120 divided by 4 is 30. 28 divided by 4 is 7. 0 divided by 4 is 0. All right, and then factorize it. All right, and once you have factorized this thing, you can now say that 9y is 7, and y equals to 7 over 9. 3y is 1, and y equals to 1 over 3. So you've got your y values. All right, but remember this question here is a simultaneous equation. This is a simultaneous, oh my goodness, we've got to go up simultaneous equation. So we've got to get the value of y and of x. And so far, we've got the value of y. Y is 7 over 9, y equals to 1 over 3. All right, so we have values of y. Now we've got to get the corresponding values of x, the corresponding values, all right? So we tackle it one by one. X, you remember, is 6y minus 4 from earlier. And so we substitute 7 over 9 from here. We substitute that in. And when you do the math, it's 14 over 4, and this is divided by 3. 14 divided by 14 over 3 minus 12 over 3. And that's 2 over 3. So this is one one solution. 2 over 3, that's your x value. This is your x value. Remember that you have to state your x value first. Your x value is 2 over 3. Your y value is 7 over 9. Now, this is the other value here. You have, right, 1 over 3 for y, and that gives you 6 over 3 minus 12 over 3. 4 is 12 over 3. All right, that gives you 6 minus 12 is minus 6 over 3, and that gives you minus 2. And that solution is minus 2. Remember, your x comes first, minus 2, and then 1 over 3. Very simple. All right, so that's how you solve your simultaneous equations. All right, solve this equation. Again, it's messy, but again, you see that 25 is 5 to the power of 2. What's 25? 25 is 5 to the power of 2. And that is 5 to the power of minus 1. So this is 5 to the power of minus 1. This is 5 to the power of 2. And this is what you should see. Once you see this equation, what are you seeing from this equation? You're seeing that there's a 1 over 5, that's 5 to the power of minus 1. There's a 25, that's a 5 to the power of minus 2. And so you substitute all of that in. The square root here is to the power of half. All right, that comes from the square root. And 5 to the power of minus 1 is here. 5 to the power of 2 comes from here. And you multiply this out. So this is half x. You multiply this, you get a half x here. The divide says a divide. And this is minus 2x minus 1. You minus 1 times 2x plus 1. You get this. All right. And this one here is 2 times x, 2x. 2 times 3 is 6. And look at the left side. It needs a little bit of tending to. The right side looks okay. It's already nice. Very nice here. It looks a bit messy still. And that's how you tend to it. All right. Because you are dividing. So it's half x minus this whole lot because you are dividing. So it's minus this thing. And when you minus this whole lot, that's what you get. Half x plus 2x plus 1. You look, I have not skipped any step. All right, that's going to make my solution error prone. So I have not skipped a step here. It's a very dangerous step to skip. Don't skip this because you have a minus and a minus and a minus. All right, if you skip this, there's a chance that you will make an error here. So here, once you see that it's half x plus 2x plus 1, that's 5 over 2x. Half x plus 2x is 5 over 2x plus 1, 5 to the power of 2x plus 6. And once you have this, you see that your base is the same. Remember, for indices, you are either going for the base that's the same or the index that's the same. And for here, for this question, it's the base that's the same. And so we can equate these two indices. 5 over 2x plus 1 equals to 2x plus 6. All right, these indices must be the same. And all you have to do now is to do the algebra. 5 over 2 minus 4 over 2 is half x. 6 minus 1 is 5. And if half x is 5, then x has to be 10. Simple. Very, very, very simple. Okay. And let's go on for another one. Go on to another one. Solve that equation. Right. So we have to solve this equation. Hence, and the word is hence. After solving this equation, use the results to solve this one. That's what hence means. Use the results of this part of the question to solve the next part of the question. So let's look at this. This is 8x cubed minus 6x squared minus 5x plus 3 equals to 0. This is right there. And we have to solve this. We have been told that we have to solve this. So let's solve this. And very, very obviously, x minus 1 is a factor. How do I know x1 is a factor so quickly? All right, I know it so quickly because if you add up the coefficients, 8 minus 6, just look at the coefficients. It's 8 minus 6. 8 minus 6 is 2. 2 minus 5 is minus 3. Minus 3 plus 3 is a 0. Hey, just looking at the coefficients tell us that the coefficients itself total up to 0, and therefore x minus 1 is definitely a factor. All right, some quick work there. Now, after this, you've got to do long division. All right, I'm not going to show long division because I don't know how to really type this out yet. All right, I'm not sure how to, type out long division yet. But when you do long division, that's what you get. Okay, that's what you get. Okay, so you get like that through long division. All right, I'm going to investigate further because I want to teach long division. I don't know how to, put it all nicely on a slide. Like all this is very easy. I use Microsoft equations. If any of you know how to do long division and put it nicely on a slide, please tell me. Right. In any case, by long division, that's what I do, what I get. And further on, when I crack this further apart, I get 4x plus 3, 2x minus 1. So 4x, 2x is 8x, that's minus 3, and that's 8x. That's 6x minus 4, 2x, that's correct. So once I have that, I have this to solve, right? X cubed minus, oh my goodness, what did I do? X cubed minus 6x squared minus 5x equals to 3, plus 3 equals to 0. I have to solve this, and I have managed to crack it. I have to manage to factorize it. So I write it in its factors. All right, so once I've done this, this is just over this side. All right, I have the factors as x equals to 1, the solution as x equals to 1. These are the factors. The solution is x equals to 1, x equals to minus 3 over 4, and x equals to half. This comes from here, this comes from there, and that comes from there. So here, this part is done. Solve the equation. This particular equation is already done. All right, I have solved it. The solutions are x equals to 1, minus 3 over 4, and half. I've solved it. Now I have to go on to the second part of the equation, the hence part. So hence, after I've solved it, hence use my solutions to solve this bit. All right. So I have to put this in, at the back of my head. I really have to store this somewhere because why? I have to use this, the solution to this equation. This equation comes from there. It comes from here. All right, I have to use the solution of this equation to solve this. So although I'm solving this, I have to have this at the back of my head. Always remember this. Whenever you have the word hence, you've got to have something at the back of your head because you are using the solution of this to solve this. All right, and so I'm putting this right here so that it kind of like flashes in my head. Okay, I can see it flashing. I can imagine it while I manipulate this. I've got to somehow make this into this format. And I immediately strike lottery because I see an 8 here and I see an 8 here. Wow, 8, 8. All right, I need a 6, but I don't have a 6 here, but I have a 3 times 2. Somehow I've got to get a times 2 somewhere here. I've got a -5 already here. I've got to have a 3, but I have an 8. So I've got to have a -5 from somewhere to get a 3. So this, you always keep this in mind because always keep it flashing in your mind because this is so, so critical. All right, so this must be flashing in your mind. Okay, so what I'm going to do is this. I'm going to transform this into as close a form as I can get to this. Now, so here 2 to the power of 3y, 2 to the power of 3y. And what I'm going to do is 2 to the power of y and the whole thing to the power of 3. And look at that. Just by looking at this first term, you know that this x should be 2 to the power of y. Just by, kind of like working on this term. All right, so 8 is there, the cube is there, the 3 is there, the cube, and the x has to be the 2 to the power of y. And there's a -6 here, so we don't have that yet, but let's not be too discouraged. We have a -3, and that's a 2 to the power of 2y, and that's a 2 to the power of 1. All right, 2 to the power of 1 comes from here, the +1. This is -5, and 2 to the power of y is here, and -5 times 1 is -5. And this is a +8. And -5 plus 8 is a 3. So we've got this term here, we've got the other term already. And we're going to get the other terms when we, when we tidy things up. So you have 8 times 2 to the power of y to the power of 3. And we have 3 times 2. 3 times 2 is 6. 2 to the power of 1 is 2. So 3 times 2 is 6. And here we have 2 to the power of y and the whole thing to the power of 2. And this is -5 to the power of y plus 3. How do I get +3? It's -5 plus 8 is +3. And if you look at this form, you will see that we have achieved what we wanted to get. Instead of x equals to 1, it's now 2 to the power of y equals to 1. 2 to the power of y equals to -3/4. 2 to the power of y equals to half. All right, 2 to the power of y has kind of replaced x. And that's what we have here. All right, so earlier we had x equals to 1, x equals to -3/4, x equals to half. So now we have 2 to the power of y equals to 1, 2 to the power of y equals to -3/4, 2 to the power of y equals to half. All right, and that's how we incorporate the hence part. Okay, so if 2 to the power of y equals to 1, y equals to 0, there's no solution for that. No value of y will give you, when you take to the power of 2, no value of y will give you -3/4. So there's no solution here. So y is 0 or y is -1. All right, when you have a -1 here, it's 1/2. So these are your two solutions, y equals to 0 and y equals to -1. So you have your solution to x as well as this y here. All right, so that's our question done. Okay, next question. Solve the equation, this equation here. And again, if you have got your multiplication, if you've got your tables already in your head, you know that 27 equals to 3 to the power of 3. The 27 here is nothing but 3 to the power of 3. The 9 here is nothing but 3 to the power of 2. So, as I've told you again and again, for indices, what you're after is a common base. Most of the time it's a common base. Sometimes it's a common index. So 27 is 3 to the power of 3. 9 is 3 to the power of 2. So let's look at this. This is what we see from this. 9 is 3 to the power of 2, 27 3 to the power of 3. Square root of 3 is 3 to the power of half, 3 to the power of half, and this is cube root of 9. So let's just reproduce this. I've not done anything here yet. And let's include everything that we have said earlier. So square root of 3 is 3 to the power of half. Square root of 3, 3 to the power of half. That comes directly from here. Now 9 is 3 to the power of 2. And let's just pause at this moment and look at what we have done. Now, at this step here, what we have done is to put everything, every single term there, we have put it to the base of 3. That's what we have done. And that's important because when everything is in a base of 3, we can combine them easily. All right, so, don't just do this math robotically, Understand why each step matters, why each step is important, why each step matters to your final solution. This step is important because it puts everything to the base of 3. That's what's so great about this step. Okay, then next step, half, you have an x there, so it's half x. So that's 3 to the power of 2, and that's cube root, so to the power of 1 over 3. So further, this is 3 to the power of 3 times 3 to the power of half x. So you combine them, it's a plus because it's multiplication here. So here we can't do anything yet because that's 3 to the power of 2 over 3. And then we can have x minus 2 over 3. And once you have done this, once this is arrived at, you have this 3 plus half x equals to x minus 2 over 3. All right, 3 plus half x equals to half x minus 2 over 3. You are equating the indices. Okay, so half x, do the algebra, you will get half x equals to 3 plus 2 over 3. Half x is when you bring this over, x minus half x is half x, 3 plus 2 over 3. All right, so that's 9 over 3 plus 2 over 3. That's 11 over 3. So x, it has to be 22 over 3. So that's your answer. X equals to 22 over 3. Simple. Okay, now let's go on. Again, messy. You look at this, and again, don't rush into the math. The problem with many students is they look at a question, they start answering. Now look at it. Given that this bit, find the value of this. It's a process of simplification. This is complicated. This is simple. Complicated, simple. From something complicated, make it simple. So that's what the question is all about. You've got a mess, clear up the mess. So you've got this bit here. Now what you do with this is, remember, you want the 6 to the power of x. This doesn't work. This looks like it works. It doesn't, because this is 6 to the power of 2x. What you want is 6 to the power of x. You need to do a bit of work here. All right, and needless to say, you need to do a lot of work here. This is quite close to this already. We need to do a little bit of work, but this is really far. All right, so let's start the work. So from this, you have 3 to the power of x times 3 to the power of 2. This gives you this, and this is your raised dot. It's a multiplication. So 3 to the power of x times 3 to the power of 2. Y times, because it's a plus here. 2 to the power of x, divide. Why is it divide? Because it's a minus here, 2 to the power of 2. All right, and again, you see two types of terms. You got to get used to it because it appears again and again and again. You got to be able to see that there are two categories here. You see that there are numbers, and there are numbers raised to some variable, x in this case. So you have pure numbers. Pure numbers are like 3 to the power of 2. It's 9. 2 to the power of 2 is 4. So you have pure numbers. You have numbers like 3 to the power of x, 2 to the power of x, 6 to the power of 2x. Numbers raised to something x, right? So what you do is you just multiply them out and separate them. Simple. What have I done? I have simply separated the numbers that are purely numbers from the numbers which have some kind of x in it. That's all. That's all you need to do. And most of the time, math is like this. You got to be clear, you got to do some separating, you got to put it in different boxes. And the boxes here means different sides of the equal sign. All right. So here 9 over 4 equals to 6 to the power of 2x is here. And this here, x and x is the same power. So we can multiply 2 times 3, we get 6x here. Wonderful, right? Because this here 2x divided by 6x, that's what you get. 9 over 4 is here. This 6 to the power of 2x divided by 6 to the power of x, you get 6 to the power of 2x minus x. And that's exactly what you want, the value of 6 to the power of x. It's beautiful. It's wonderful. So what's the answer? What's the value of 6 to the power of x? The answer is 9 over 4. Right? So, oh, we've come to the end. My goodness. Okay, now we've come to the end. And I enjoy this. I don't know whether you're enjoying it, but I'm enjoying myself tremendously because all I do is just solve a lot of questions. And I explain to you how I'm doing it. Now, next week will be certs, I think. All right, next week, if I'm not wrong, is certs. And after certs, what I'm doing is I'm going to do logarithms. All right. Now, I have my email here, and if you have questions on certs, please send them over. If you have questions, because next week is another week that I can't reach my office. I don't have books. I'm just rummaging through Google, Google to search for questions. So if you have some questions on certs, you're welcome to send them over. And on top of that, we're going to do certs, and I will discuss with the people who are so kindly hosting me. All right. And I will ask them whether I can have a further week or not. And if I have the further week there, I will do logarithms. Okay. Certs followed by logarithms. Okay. So write to me, tell me how you're finding it, and keep safe. Thank you for watching, and I will see you next week for certs, SURDS, certs. All right.